4, and then eventually the third, right? 1 over n.
Go him.
All right. I have the shirts, but I don't think they gave me your shirt. I think they gave it to somebody else. The UIL shirt. Yeah. All right, so let's look at the natural exponential function today. Yesterday we looked at the natural log. Today we're going to look at e to the x. Do you guys remember working with e to the x? Remember when we were doing limit problems and we had the limit of some exponential function? Yeah? And we had to find the limits. We had to pay attention to the number, to the base, and we would say, oh, is it more than 1? Or is it between 0 and 1? So we could know if it was exponential growth or exponential decay, right? Do you remember that? Okay, remember that they also had asymptotes? Yeah? What would be the horizontal asymptote for e to the x? 0, right? Because it has plus nothing, right? So that plus k was the horizontal asymptote. So here, e to the x has a horizontal asymptote at 0. Why do you think that is? So, well, not something, but specifically in this case, what? E, so like e to any power, Caitlin, will never equal what? 0, right? It doesn't matter what x value I plug in, my answer will always be what? Will it even be negative? No, right? It will always be a positive number, right? So when I plug it specifically into this function, right? So if I put in like negative 100, that would give me e to the negative 100, which is really 1 over e to the 100, which is just a fraction, right? A really small positive fraction. So it's a really small positive number. Do you understand? Yeah. So that's why we have this horizontal asymptote. That's also something to take into consideration, especially when we start doing sign lines and you have to plug something in here, right? So it doesn't matter what I plug in there, my answer will always be what? Positive. So on that sign line, when I plug that into, let's say that's the derivative, I know it's just going to be positive all the time. You understand? So, let's see e to the 0. What's e to the 0? 1. What's e to the first? E, which is not that, it's 2.718, right? So the curve should look like this, come really close to 0, and then go up and go that way. So scratch that other point, I'm sorry.
Which one is that?
This one, it's 2.718, which is right under 3. So just like we looked at the logarithmic function, let's look at the exponential function and tell me some characteristics about it. So what do you notice is happening? It's always what?
Increasing.
It's always increasing, right? Okay, so let's write that down. So when something is always increasing, we could say that it's what? Monotonic, right? Okay, could also be always decreasing. So for example, if it was exponential decay, right, that would be always decreasing, so therefore it would also be considered monotonic. All right, what could you tell me about the derivative of this guy? It will always be positive, right? If I draw tangent lines, all of my tangent lines will always have what kind of values? Positive slopes, right? Okay. All right, what's the concavity on this guy?
Concave up.
Concave up. Very good. So if I did tangent line approximations, those tangent line approximations would always be what? Overestimates or underestimates? Underestimates, because my tan lines would be below it, right? Okay, cool. What's the domain for this function? What are the x's that I can go to and touch my graph? Or get an answer? Negative infinity to positive infinity? Okay, what would my range be?
0 to infinity.
0 to infinity. Very good. Excellent work. Okay? Now let's look at these limits of exponential functions and review. Okay, so remember there was always just two answers when we were doing limits of exponential functions. The answer was either the horizontal asymptote or some infinity, right? So if I look here and I'm going all the way to the left, where is the curve going? It's getting really close to what?
0.
To 0, which is the horizontal asymptote, right? If I go forever to the right, which is this one the same, where's the curve going? Positive infinity. So remember when we did those problems, we had to pay attention to the orientation of the graph, right? We had to perform the reflections to have an idea of what it looked like, so that way we could know if I approach that infinity, then it's going to that asymptote or it's going to this infinity. You remember? Okay, don't forget those because they will come out on the test, the AP exam. Pretty cool? Alright, do you guys remember how ln and e are related to each other? Or what are they of each other? What?
Inverses.
Inverses, okay, very good. So they are inverses of each other. So what does that mean? What do two things do to each other if they're inverses of each other? They cancel each other out. Very good. Okay. So does anybody remember what you would do if you were trying to find the inverse of something? What you had to do? Remember when your teacher gave you like an equation and then she said, find the inverse of this equation. What was the first step? Anybody remember? From pre-cal? You would flip it? What do you mean by flip it? The reciprocal of it? Not really.
Do you solve for x?
We have to solve for something, but before I do that, I have to do something to the problem, which is the main idea of finding it in. Anybody remember?
Switch out the x and the y.
Very good, Monse. So we have to switch the x and the y variables, right? So we switch the x and the y. The moment we do that, that already represents the inverse. Then your teachers would train you to make it y equals and then relabel it as the inverse of the function. You remember that? Yes? We're going to practice that a little bit more on Monday. We're going to review that in case you forgot it. But since we're talking about it right now, we're switching the x and the y. The domain is the x, right? The range is the y. So if this is the domain and the range for the natural exponential function, the domain and the range for the ln, right, which is the natural log function, should be swapped, right? So let's check that and see if it is. Okay, because we did that for the other one. So here the domain is from negative infinity to infinity. That means that the range in the other one should be negative infinity to infinity. Is that true? Okay, and then here the range was from 0 to infinity, so on the other it should be the domain, which is also true. Okay, so the x values and the y values swapped each other. Cool? So don't forget that. Let's write it down before we forget. ln and e are what? Inverses of each other. What do they do? They cancel each other out. So for example, if I had e to the x, okay, and I wanted to cancel that out, I would take the ln of it, right? That would cancel out and we would just be left with x. Or if I had ln of x and I wanted to cancel out ln, I would do a process called exponentiating. So I would basically make that the power of e. I would say e to that power, and then those two would cancel out and we would simply be left with x. Understand? Cool? So we're going to do a couple of examples of solving exponential equations. This is an exponential equation. This is more of a what? This is exponential, right? Something to a power, and this is a logarithmic problem, right? It has ln of something, right? So whenever you're doing an exponential function, which is this one over here, you're trying to solve for the variable, and the variable is where? In the exponent, right? So whenever the variable is in the exponent, I need to be able to bring that exponent down, and the only way to bring it down is by using logarithms, okay? So you could think of it the way sometimes teachers tell you is to take the log of both sides, right? Or you can just realize that by doing that, you're just rewriting the problem in log form, okay? So that's basically all you have to do. It's just, if it's an exponential form, you rewrite it in log form. If it's in log form, then you rewrite it in exponential form. And we already went over that on our foldable, right? How to go from one form to the other. You remember that? So if it's an exponential, how could I convert that to a log? You say log base what? A of whatever the answer was equals the exponent, right? And you also have to be able to go the other way around. Okay? So let's look at this one here. So how would I rewrite this one?
ln of 7.
Rewrite in log form. So this would be like log base what? E of
7
equals
x plus
x plus 1. And we can replace log base E with what?
1
ln, because whenever that is there, it's understood to be a base of what?
e
E. Okay? And now how can I finish this to get x?
move the 1
minus 1, so that's just ln of 6? No? So I can't just put those two together?
no
They're underneath each other. You can't do that?
no
No, okay? It's ln of that, that's why it's always good to put parentheses around it, so you know that nothing can be added to it or subtracted from it or anything. It's all together. ln of 7 is some number, and then that number, you're going to take away 1. Okay? And then this process, you could go to your calculator, type it in, and then get an approximation for that value. We always round to 3 decimals, okay? So I don't have calculators today, but your cell phones do have ln on them, and your cell phones do have e on them. So you can put those into your calculator on your phone, and you can do them on there. Okay? If you don't know that they're there, all you do is turn your phone sideways, and then it adds all the extra features to the calculator. Okay? You got it? Alright, so will somebody type that in and tell me what they get?
I press ln and it says error. Oh, I'm sorry.
Yeah, put 7 ln minus 1. What do we get for the approximation? What? 945, what's the first number?
0.
Oh, 0 point?
Yeah. 4946.
0.946? What's the number next to the 6?
It's fine.
Oh, it's 5.9?
Yeah.
So it becomes a 6. Very good. Okay. Wanna try another one like that? Let's try another one in exponential form, so that way you can see that you have to rewrite it. So if we have e to the 2x plus 5 equals 10, okay? It's an exponential form, I need to rewrite it in log form to solve it. What would this be as a log? ln of 10 equals 2x plus 5. So how did you go straight to ln? Because you know that it was going to be log base e, so I can go straight to this step. Very good. Okay? That's the point that I want you to get to. If you can't do that right off the back, then do these 2 steps. Write it like this first, and then convert it, okay? Alright, so what do I do next?
subtract the 5 and
Minus the 5. So we got ln of 10 minus 5 equals 2x, and then divide by 2, so the whole thing divided by 2, and we're done. How do I put that in my calculator? So I guess you'll have to press 10 ln, and then minus 5, right? And then whatever you get, press divide by what? By 2. Type that in there and see what we end up. What you get, Mons?
Negative 1.349.
Negative 1.349? Yeah? Round to 3 decimal places, okay? Cool? Alright, so this is not calculus, this is all review from Algebra 2 and Pre-Calc. Let's try this last one here. So this one's in log form. Okay? So you must go to what?
Exponential form.
Exponential form so you can solve it. What would this be in exponential form? What's the little base for this ln? E. It's not written there, but it's understood to be there. So this would be e to the 5th equals
2x minus
2x minus 3. Now can I solve that? Add the 3. E to the 5th plus 3 equals 2x. And then divide by 2. And we're done. Type that in your calculator and see what you have. You have to put that one 5 and then E, or you can put E and then 5. How does that one work on the phone?